Ahoy, mateys! My development journey of the first version of the Geo-Distributed Messenger has ended. So in this last article of the series, I'd like to talk about multi-region database deployment options that were validated for the Messenger. The high-level architecture of the Geo-Messenger is represented below. The microservice instances of the application layer are scattered across the globe in cloud regions of choice. The API layer, powered by Kong Gateway, lets the microservices communicate with each other via simple REST endpoints. The global load balancer intercepts user requests at the nearest POP, point of presence, and forwards the requests to microservice instances that are geographically closest to the user. Once the microservice instance receives a request from the load balancer, it's very likely that the service will need to read data from the database or write changes to it. And this step can become a painful bottleneck, an issue that you will need to solve if the database is located far away from the microservice instance and the user. In this article, I'll select a few multi-region database deployment options and demonstrate how to keep the read and write latency for database queries low regardless of the user's location. So, if you're still with me on this journey, then, as the pirates used to say, weigh anchor and hoist the mizzen, which means, pull up the anchor and get this ship sailing. Multi-region database deployment options. There is no silver bullet for multi-region database deployments. It's all about trade-offs. Each option provides advantages, while others cost you something. DB, my distributed SQL database of choice, supports 4 multi-region database deployment options that are used by Geo-Distributed applications. Single stretched cluster. The database cluster is stretched across multiple regions. The regions are usually located in relatively close proximity, e.g., US Midwest and East regions. Single stretched cluster with red replicas. As with the previous option, the cluster is deployed in one geographic location, e.g., North America, across cloud regions in relatively close proximity, e.g., US Midwest and East regions. But with this option, you can add red replica nodes to distant geographic locations, e.g., Europe and Asia, to improve performance for read workloads. Single geo-partitioned cluster. The database cluster is spread across multiple distant geographic locations, e.g., North America, Europe, and Asia. Each geographic location has its own group of nodes deployed across one or more local regions in close proximity, e.g., US Midwest and East regions. Data is automatically pinned to a specific group of nodes based on the value of a geo-partitioning column. With this deployment option, you achieve low latency for both read and write workloads across the globe. Multiple clusters with async replication. Multiple standalone clusters are deployed in various regions. The regions can be located in relatively close proximity, e.g., US Midwest and East regions, or in distant locations, e.g., US East and Asia South regions. The changes are replicated asynchronously between the clusters. You will achieve low latency for both read and write workloads across the globe, the same as with the previous option, but you will deal with multiple standalone clusters that exchange changes asynchronously. Alright, matey, let's move forward and review the first 3 deployment options for the Geo-Messenger's use case. I will skip the 4th one since it doesn't fit the Messenger's architecture, which requires a single database cluster. Thanks for watching. Please subscribe.